This is what we call our CMS108. The big difference that we're going to see is this is actually a flying dot laser. So it modulates back and forth, so when you actually see it on the part, it looks like a line. If you imagine like your laser pointer that you have, typically moving it real fast, it looks like it creates a line, kind of the same type of process. So this scanner actually moves at a much higher rate of speed. So we can still do 30,000 points per second, but each line now has 2,000 points per line versus 1,000 like we had with the RS1.
So a lot more, it can collect a lot more data.
A lot more data.
In the same amount of time.
In the same amount of time,
okay.
Correct. A couple of the other nice things about the CMS with different colors, as you see, we've got a part here that has white, black, and silver. The nice thing about this, the operator does not have to do any adjustments to the scanner at all. Everything is done on the fly. This scanner automatically adjusts for the different colors and ambient light. So as you can see in our hall, we've got a lot of bright lights from above. We've got all our video lights, so it's going to show us how well this works, and I'm not going to have to touch a thing.
Okay, so with the last scanner that we saw, you had to essentially auto-calibrate it for the particular reflectivity,
exactly, different colors.
This one does it on the fly.
Does it all on the fly,
okay.
So the operator doesn't have to touch a thing. One of the other nice factors about the CMS is you can actually adjust the scan angle or the laser line. So if you have a part that you need a little bit more detail on, you can tighten down the angle and take a lot more dense point cloud.
So it's taking the same amount of data, but over a smaller distance.
Just a smaller distance.
Okay, so
exactly,
denser. Okay.
Exactly. So what that actually gives us in the end is a more accurate system where the operator does not have to touch a thing. Okay. So the first thing I want to show you today is to kind of demonstrate that. I've got a probe here that has a steel on the end, also with a little black knob. Then we go to carbon fiber material, silver again, and then a white ceramic. So what we'll do is we'll set this up on the part. I'm going to point the laser at the part, click the button, and we'll start scanning. So right on the screen, you're going to see me go from the silver. Now we're on the carbon graphite, going up to the silver again, and then right to the white ceramic. And as you notice, I didn't do anything to change that. If we come around to the side, we can get a little more data so we can look like we've actually got our full sphere, or our cylinder here.
And it looks like you're not getting any noise in there either.
No noise whatsoever. You see no reflective points out on the screen. So it's just, it does everything right on the fly.
So we've got a silvery, almost mirrored surface. We've got a white shiny surface and a black shiny surface.
And the black shiny surface, right, correct. We'll change our program here for our bumper.
And what is this? What is this thing sitting in front of me here?
This is a bumper for road armor. This is actually manufactured down in Central Illinois, a company called Morton Industries. So they were very kind enough to let us borrow a couple of these for the show. Okay, now this is where what we want to do is I had the angle set up on our probe for a real tight surface here. So let's just cancel this 1 second. Let's change our scan angle. We just come into our scanner. Let's say open it up. So now we're going to have, instead of about a 25 millimeter line, we're going to have a 130 millimeter line.
130 millimeter.
Yes.
That sounds like a pretty wide stripe.
That's quite a very large stripe. So now we'll come back in here and we'll say run our part here. Okay, now we're going to have a lot more data on the screen.
Okay. So now with one pass, you can just go right over the whole.
With one pass, yeah, you can go right over the entire part. Now we'll click the button. It's going to say calculate circle 1, calculate circle 2, 3, and 4. So now you notice on the screen, it actually moved us right onto our program. We've got 4 holes in the back. So all I'm going to do is just scan right across all 4 of them. And I can do this in any order. Doesn't have to go 5, 6, 7. I can go in any order. You notice the red that it's highlighting. It actually tells the operator exactly where to measure. If I've taken enough data, the red disappears and I know I'm ready to move on to the next feature. So we click the button to say OK. Now what we're going to do is you're going to see the very front of the part. I'm going to scan the front and do what's called a surface color map. and this will tell us where our part is high and low. So I'm just going to do a couple scans across our surface, and this is where you can see my standoff. I'm quite a bit away from that part.
You're about 8 inches off right now.
About 8 inches off.
Yep.
So we'll just run across and do one more scan. So you see basically with 3 scans, I've got the whole face of this bumper here.
So is this the scan width 129 millimeters, you said?
129 millimeters, exactly.
Is that the biggest scan out there?
That's there is one scanner out on the market that is a little bit larger, but it's not as accurate.
All right.
The accuracy of the scan. Did I mention the accuracy of the scanner?
No, you didn't mention the accuracy. What is
The actual accuracy
of
of this scanner is 20 microns.
Oh, wow.
And if you look at that, add the scanner to a 2.5 meter arm,
right,
you're at a total system accuracy of about 58 microns.
And that's true even with the wider scan?
With the wider scan also.
Wow, okay.
Yep.
Right.
Now it tells me all features have been solved. We click the button, and what it's doing is comparing all of those points directly to our CAD model, and it's going to create our color map. So what we see on the screen now is we see the greens, light blues, and dark blues. What that tells us is anything in green is within tolerance. Anything in the blue means that the material is low. So we can kind of tell we've got just a little bit of a tilt down towards that bottom corner.
And this would typically be used for inspection purposes? Is that normally what you're doing it for?
Exactly, exactly. What we're showing here is our PCDMIS inspection software.
Okay. Now you mentioned the accuracy is 20 microns, right?
20 microns for the scanner.
How often do you need to calibrate the unit?
This unit here, once you calibrate it, the calibration is permanently stored inside the software.
Okay.
So you don't have to calibrate it every time you attach it.